So this is the 2018 FRQ question 4. We're doing only part D. And we have a height of a tree is given by G. So G is the height. And X is the diameter. It says when the tree is 50 meters tall, the diameter of the tree is increasing at the rate of 0.03 meters per year. So let's take a look at that. That is a derivative, okay? And something is changing as something is changing. And what's changing? The diameter. Well, the diameter is X. And that's increasing, so it's a positive meters per year. And they want the rate of change of the height of the tree. So let's look at that. When the tree is 50 meters tall. So they want the rate of change of the height when, oh, and the height is G. That should be a G, not an H. We were told G when G is 50. Okay, so we need a function with X and G in it. Right there. There's our function with X and G. So we can use that to get our related rates. So G is 100x over 1 plus x. So we need to take the derivative, right? Well, the derivative, okay, so let's look at this. X is a function, G is a function, T is our variable. So our variable's T. In this case, every G and every X should be considered a function, not your variable. So the derivative of G, by definition, is dg dt. Now we need to take the derivative of the right side, but the right side is a quotient. So it's a quotient rule. So we take low, and the derivative of the top, d high, derivative of 100x is 100. That's the constant, but x is a function. What is the derivative of x? By definition, it's dx dt. That's low d high minus high, so I copy the top. D low, the derivative of 1 is 0, and derivative of x, by definition, that is dx dt, all over low squared. So there is our derivative. And we want dg dt when g is 50. So all these should be happening when g is 50. So I'm going to put that kind of sloppily in there. We're trying to find dg dt. We have dx dt and we have x. So let's plug everything in. X. Oh, do we have x? That's a good question. I think from the chart, when G is 50, do we know X? No, I gotta find that. Oh, we have the equation. Duh. Okay, so we have to do more work here. So we need to know X, X, and X, but we're given G is 50 because we're told when the tree is 50 meters tall, and that's G. So how do I find X? Well, I have this relationship. G is 100x over 1 plus x. Well, if I set G equal to 50, then I can solve for X, because that's the particular time that I want these rates. Well, I'm going to multiply both sides by 1 plus x. Those are going to cancel out on that side. So I'm going to get 50 plus 50x equals 100x. Subtract 50x from both sides. I'm going to get 50x. Divide both sides by 50. X comes out to be 1. So you have to calculate x at that time. We use that formula to do that. And now I can plug it in everywhere. X is 1. dx dt is 0.03. And this x is in meters. So I should have a meter here. Let me look back at what these are. The units of these should be meters. So that's a meter. Let me look at what that 100 was. Okay, and then minus 100 times 1, because we calculated x. dx dt we calculated 0.03 meters per year. And 1 plus x, but x is 1. And that's squared, but that's going to be square meters there also. Why? Because this is in meters and it's squared, so it's going to be square meters. I'm missing one more unit. This whole thing, the 100, there's another meter there. Hold on, folks. Let me double check my units. My numbers are good. It's just my units right now. So that x we put in as a meter. That 100 times x, there's going to be another meter there. I need my meter squared. So basically I need that to cancel out. So I'm going to be left with meters per year. So there's another meter there. I have to kind of think about this a little bit. But basically that's our answer. You don't have to simplify that. Does it ask for anything? No, they just want dg dt. So that's your answer. If you simplify it, you'll get a simplified answer. But that should be